All right. So our purpose today is to take ourselves to a higher level with this understanding. It is the last lesson that goes with chapter 9. And by the end of class today, I would like you to be able to find and use all three measures of deviation and I'm going to put a colon there and I'm going to list them so that you know what three they are to know what you can do with it. First one is range. The second one is the IQR. That's that interquartile range. And the last one is called the mean absolute deviation. And we like to sometimes abbreviate that as MAD. When I look at those three measures of deviation, only one of those is brand new today. Which one would be the academic vocabulary today, the one that we haven't done at all before? Caleb, what would it be? The MAD, the mean absolute deviation. Finding the range for a set of data, you've done that. Finding the IQR, we've done that. Finding this MAD thing, this mean absolute deviation, we haven't. All of these words talk to us about how spread out is our data from the center. This one is going to be the trickiest. Not hard math, weird math. So we're going to have to really pay close attention. And I can't have anybody distracting other people. We've got to pay attention on this one because it's going to be a little bit tricky. So I think sometimes it's easiest to show you what it is by an example and work through it that way. What we're trying to find out is, you know what the mean is. That word's not new. Absolute is like a measure of distance. What does deviation mean? If I were to say, do not deviate from the rules, what does that mean? Wes, what does it mean? Don't go away from the rules. Sometimes they talk about that person's a social deviant. That would be somebody that when we look at the normal group of people, the person who really stands out, and often it has a negative connotation. It might be a person that stands out and is more violent than others. Someone that is more likely to abuse different substances than others. That they deviate from what we consider to be normal. Don't deviate from the rules means don't leave what we consider to be the normal. Well, what we're going to try to find out is we're going to find out for our set of data, how much does each piece of data deviate from the normal? And this normal measure is going to be the mean. So, if we were looking at this set of data, a 1, 3 2s, 3 4s, and a 5. So we have this set of data, and someone says, well, okay, so let's look at this data, and I want to know about how the data deviates or how different it is from the normal, from the mean. This is how we do it. We might first look at the range. It's a range of 4. The IQR, we could work our way and figure it out. But this one, to find this, our step 1 is find the mean. And that is no different than how we were finding the mean as a measure of center. So we want to find what's the mean of that data, and I love seeing lots of you grabbing your calculators and starting to do this. We need to, what operation do we have to do to find the mean? Courtney, what do we have to do? Courtney Huffman. Right, we need to add them all up and divide by how many numbers there are. So go ahead and do that. Let's add them all up. Caitlin Dyer, what did you get when you added them all up? That's your total answer. Do you remember what it was before you did your division?
24.
You got 24. So when we add them all up, we get 24. We divide by 8 because there's 8 pieces of data. And the mean of that data set is 3. So far, so good?
Yes.
That should feel like review. Because it is. Step 2. Graph the data. Now, sometimes the data is so spread out that you're not going to want to do this step. And I'll show you how we can do it without it. But for now, just so that you can see what I'm talking about, I want to graph it. So graphing the data for this one would be, let's see, a 1, 2. Do I have to write a 3 down? Yes. It doesn't matter if it has data or not. I have to write everything between the maximum and the minimum. So there's a 1, there's 3 2s, 3 4s, and a 5. So I just did a quick graph of the data. It allows me to see how the data kind of lays out. This one, interestingly, there's no data on the mean. But other than that, this data is really symmetrical. Like if I folded it in half on the 3, it would all match up really pretty. So I graphed the data. It allows me to see what we're talking about. Now, this piece of data right here, I'm going to put a box. This is the mean. The 3 was the mean. How far away from the mean is that piece of data? Think that through carefully. How far away from the mean is this piece of data? So you start at this 3 and you do your counting. How far away? Isaiah, how far? 2. It's 2. 3 minus 1 is 2. So I'm going to write down a 2 for that piece of data right there. This one is 2 away from the mean. All right, the next piece of data I want to do is I want to do this one right here. How far away from the mean is that piece of data? Jared?
1.
It's 1 away. So now I'm going to write a 1 right here to list for that. And this one is also a 1. And this one is also a 1. Whoops. Sorry. Not a plus. A 1. So I have a 2 and I have 3 1s. Do you understand where I got them all?
Yes.
All right, so let's go over to this piece of data right here. How far away from the mean is that piece of data? Isabel, how far away is it? You just talked because he talked. Brett, what do you think it is? Yeah, what you think it is. How far away is 3 from 4? It's 1. Can we have negatives with distance? No, we can't. There's no such thing as a negative distance. So this one is 1 away. This one is how far away? 1. And this one is 1. What about this one out here? 2. Then I take all those and I add them up. Now I'm just adding my distances. That is step 3. So step 3 is add. So add. And I'm really adding their deviation. How far did they deviate from the mean? How far away from the mean did they travel? Leah, what did you get when you added them?
I didn't understand when you're like graphing them and how you with the 1 you got the 2.
You don't understand the distance.
No.
All right. You understood how I graphed them. You know where I put the dots. So, see this dot right here? That's a piece of data, isn't it? Did you understand how we got that the 3 was the mean? How far away is 1 from 3?
2.
That's why I wrote a 2 down. How far away is this 2 from 3?
1.
That's why I put a 1 down. You're good with it now? Okay, you're not the only one confused. No doubt in my mind. Who got a sum for step 3? Brendan, what did you get? 10. So when we add these all up, we get 10. That's step 3. Step 4 is divide the sum. So divide the sum by number of pieces of data. So we are basically finding the mean of the distances, right? Because we added up all the distances, and now we're dividing by how many distances were there. So 10 divided by 8 equals, JT? 1.25. That right there is the MAD.
Oh, I get it.
That is how far away from the mean most of our data falls. All right, so one last thing, and you're going to be ready to go.
Why do we have to find the mean?
Because that was how far we were finding our distances from. That became our center to figure out how far the distances were all. We're finding the mean of the distances from the mean. All right, and the reason we do this is actually pretty fascinating. Lots of scientists use this. If we have what's called a normal curve, a normal set of data, when we graph it, it looks like this. And the highest point of our normal curve is the mean. We expect in a normal group of people or a normal group of data sets, we expect it to be most common for them to have the mean, the most people to be right there. But what we want to know is, okay, so if that's the most common, when does it get weird? When does it get to the point where you go, well, that person's really odd. That person's a deviant because they deviate from the mean so much. Well, so if we were to say, for example, a normal IQ, a mean IQ is 100. You can probably don't know your IQ. In fact, they say you should not know your IQ. That it's not healthy to know it.
Why?
Because then we start to try to live to it. And it's better just to live. IQ is your intelligence quotient.
Wait, no, how do you
And listen, it's your intelligence quotient. And what it says is generally what your capacity for learning is. It doesn't mean you will learn it all because some people don't work hard. And some people find out that their capacity for learning is this much, and they work so hard that they actually learn this much. So people, it really doesn't mean that much, and a lot of times, it used to be that they would do this, like even on kids, that they would do tests and they try to find the IQs. And they started to realize that really IQ doesn't mean much, because so you have a normal IQ. If you don't work hard, you look like you don't. So, but they did find that in a normal population, the average is 100. How about listening? And so then they found out that the MAD, when they found everybody, a great big huge group, they found that the MAD is 10 IQ points. So that means that going this way, one MAD would put me at 110. Going this way, one MAD would put me at 90 because I subtract it or add it to the mean. And they have found that 68% of all people or all data pieces fall within one MAD of the mean, one step away from the mean. They expect that most people are right in that real tight range. Then they said, well, what if we went out 2 MADs? What if we go out another one? That would be to 80, right? And this would be 120. Just adding another 10 on. For that one, they found for that distance that 95% of all people IQs are between 80 and 120. And then they go out one more step. So this would be 70, and this would be 130. And they found for that one that 99.7% of all people fall within that range. Just stepping out 3, and they start calling them just standard deviations. They don't call them mean absolute deviation. They just say stepping out 3 standard deviations, everybody falls in that. So you can imagine that when they test somebody and they find out that that person's IQ is 166, they look at that and go, whoa, that person is way outside the typical. That person might even get their own name, like a genius, right? So that's what does there. But the other thing they look at is maybe the other way. What if they test somebody and their IQ is 50? Don't you think that person is also exceptional? They're the exception to the rule and probably need some exceptional help to make it so that they can be successful. So this normal curve is where you use that MAD, that standard deviation, is because it tells us where we expect the data to fall. And if it's not falling in those ranges, then we know that it's outside. It's deviating from the normal.